I look at the monitor again and feel the coffee growing cold in my hand. It's 3 in the morning and there's something in this data that won't let me sleep. An object the size of Manhattan is approaching the sun at 200,000 kilometers per hour, and everything we knew about interstellar visitors just became irrelevant. I don't know if you're ready for this. I wasn't either. The first time I saw the numbers, I thought there was an error. We all did. It's easier to believe in a telescope malfunction than to accept what the data is screaming. But here we are, looking at the same impossible figures again and again, and every instrument tells the same story. 3I/Atlas arrived unannounced in July, like a whisper in the noise of the universe. Detection algorithms caught it first, just another point moving against the background of stars. Routine, daily bread for astronomers cataloguing space rocks, except this point moved differently. I remember Sarah's email. She works on the orbital analysis team at Gemini Observatory. She wrote only 3 words. Check this now. She attached preliminary trajectory calculations. I opened them expecting another Kuiper belt object with an eccentric orbit. What I saw made me stand up from my chair. The object came from outside, not from the outskirts of the solar system, but from outside, interstellar space, the third confirmed visitor from beyond our cosmic neighborhood. Oumuamua was the first in 2017, that cigar-shaped thing that accelerated for no apparent reason as it left the sun. Avi Loeb suggested it might be an artificial solar sail, and the scientific world crucified him for daring to think outside convention. Borisov arrived in 2019 behaving like a normal comet, and everyone breathed easier. But 3I/ATAS, this is different. The trajectory aligns with the ecliptic plane to within 5 degrees. Do you understand what that means? A random object from interstellar space has a 2% probability of arriving at that exact angle. 2%. Those aren't odds you ignore. Then came the spectroscopy results. My hands actually shook when I read them. 95% carbon dioxide, 5% water. Every comet we've ever studied shows the opposite ratio. Water dominates. Ice defines them. But this thing is basically a frozen CO2 brick hurtling through space at relativistic speeds. It formed in the thick disk, Maria said during our video call last week. She's been studying galactic chemistry for 20 years. 10 billion years ago, maybe older. The ratios match theoretical models for that era, but we've never actually seen material from that epoch. So it's ancient, I replied. Ancient doesn't cover it. This thing might be older than most stars in our galaxy. The mass calculations came back next. I was in the cafeteria when Tom called me. He never calls, always emails, always formal, but his voice cracked when he said, "It's 1,000 times more massive than Oumuamua. 1,000 times." I dropped my sandwich. Someone nearby laughed, thinking I was clumsy. They didn't know I had just learned that something the size of Manhattan Island, made of materials from the dawn of the galaxy, was approaching our sun. And it gets worse. The perihelion happens October 29th. Behind the sun. During a critical observation window, it will be hidden from most of our instruments, just when we need to see it most. The sun itself blocks our view. Convenient, Avi Loeb said in the conference call. His voice was calm, measured, but I could hear the excitement underneath. If I were planning an Oberth maneuver, I'd time it exactly like this. You're talking about the mothership hypothesis again. Director Chen interrupted. She sounded tired. We've been through this. Have we? Loeb leaned toward his camera. Explain the trajectory. Explain the composition. Explain why an object this massive, this old, arrives at this angle with this timing. Explain all of it with natural processes and I'll shut up. Nobody explained it. The silence on that call lasted 15 seconds, an eternity in a room full of scientists paid to have answers. Here's what keeps me awake. An Oberth maneuver is when you fire engines at perihelion, the closest approach to a star, to maximize velocity gains from gravitational assist. It's what we do with our own spacecraft. Cassini used it. Voyager used it. If something intelligent wanted to use our sun as a slingshot to change trajectory or accelerate to incredible speeds, it would do it exactly when 3I/Atlas reaches perihelion. Behind the sun, where we can't see. What if it doesn't leave? Sarah asked me yesterday. We were reviewing the latest JWST data. What if it uses the maneuver to stay? I looked at her. Really looked. She had dark circles under her eyes. None of us are sleeping much. Stay where? In solar orbit. What if capture is the goal? What if we're about to have a permanent visitor? The thought hit me like ice water. An object from the thick disk, 10 billion years old, arriving at a statistically improbable angle, composed of materials we've never seen in comets, massive beyond any previous interstellar visitor, timed to perform an invisible maneuver behind the sun. What if it's not passing through? What if it's parking? The Mars flyby happens first. October 15th. It passes close enough that the Mars orbiters will get good data. Everyone's hoping for high-resolution imagery. Everyone's afraid of high-resolution imagery. What if we see structures? Tom asked during lunch. He was picking at his food, not eating. What if there's geometry that can't be natural? Then we rewrite every textbook, I said. No, he shook his head. Then we face the fact that we're not alone, and never were, that something out there builds things, that something out there travels between stars, that maybe something out there is coming here with intention. My appetite disappeared too. The chemical fingerprint bothers me most. I've read every paper on cometary composition published in the last decade. Water ice, silicates, some organic compounds, trace metals, standard recipe, but 95% CO2. That's not a comet. That's not anything we have a category for. Unless it's artificial, Maria said. She was drunk when she said it. 3 glasses of wine into a video call at midnight. Unless someone built it from materials optimized for something other than naturally forming in a protoplanetary disk. Built it for what? She laughed. It wasn't a happy sound. I don't know. Long-term storage? Shielding? Maybe CO2 ice is easier to harvest in the thick disk. Maybe it's better radiation protection for a 10 billion year journey. Maybe I'm insane and need to sleep. But she wasn't wrong. If you wanted to build an interstellar vessel, you'd use local materials, and if you launched from the thick disk epoch, you'd use what was abundant there. Carbon dioxide ice would be everywhere. Water, less so. It's practical. Efficient. Exactly what engineers would do. The Hubble observations showed brightness variations inconsistent with a uniform surface. Either it's tumbling in a complex rotation or different sections reflect light differently. Natural comets tumble chaotically. This thing's variations show periodicity, patterns. It's spinning on purpose, Tom said, showing me the light curve. Look at this. Every 43 hours, same peak intensity. Every 43 hours, same valley. That's stable rotation. That's controlled. Comets can have stable rotation. Not for 10 billion years they can't. Not through the gravitational chaos of interstellar space. Something is maintaining this. I didn't have a counter-argument. I still don't. The JUICE spacecraft will observe it in November, after perihelion, if it's still here. If it hasn't broken apart or accelerated beyond tracking capability, the European Space Agency scheduled emergency observation time. They're calling it high-priority science opportunity. That's bureaucratic code for holy shit, what is this thing? Director Chen held a press conference yesterday, very carefully worded. An unprecedented opportunity to study material from the early galaxy. Trajectory suggests interstellar origin. Ongoing observations by multiple facilities. Results forthcoming. She didn't mention the alignment probability. She didn't mention the composition anomaly. She didn't mention that Avi Loeb thinks it might be a mothership carrying smaller probes. I don't blame her. How do you tell the world that we might be watching first contact unfold in slow motion? My daughter called last night. She's 7. She was watching a documentary about space and wanted to know if aliens are real. Nobody knows, I told her. We're looking. Will we find them? I thought about 3I/8L. I thought about October 29th. I thought about what might happen when something the size of Manhattan, older than most stars, performs a maneuver behind the sun where we can't see. Maybe sooner than we think, sweetheart. She laughed, delighted. She thinks space is an adventure. She doesn't know her father is terrified that she might be right. The worst-case scenarios keep multiplying. Sarah made a list. We were half joking. Then we weren't. What if it's a seed ship? 10 billion years is long enough for civilizations to rise and fall 1,000 times. What if someone launched this before Earth existed, programmed to travel until it found a suitable star system, then deploy whatever it's carrying? What if it's a weapon? Some ancient war, long finished, but the weapons still travel. We could be collateral damage to a conflict that ended before our sun ignited. What if it's a test? Maybe advanced civilizations send these things out to see which stars develop intelligent life. Maybe we just noticed the exam proctor arriving. What if it's a refuge? Civilization-ending events could force an evacuation, pack everyone into generation ships and launch toward distant stars. This could be a lifeboat from a disaster 10 billion years gone. What if it's dead? A tomb ship. The last remnant of something that couldn't survive. We might be excavating a grave. What if it's alive? Not a ship at all, but an organism evolved for deep space. Something we have no biological framework to comprehend. Something that feeds on starlight and breeds in the darkness between galaxies. Stop, Tom finally said. You're spiraling. He was right, but the thing is, one of these scenarios might be correct, or something worse we haven't imagined. The signal detection story leaked last week. Someone on the Arecibo team talked to a journalist. They're claiming periodic radio emissions every time 3I/ATLAS rotates into a specific orientation. Weak signals right at the edge of detectability. Could be instrumental noise, could be natural plasma interactions with the interstellar medium, could be a beacon. The government shutdown timing is suspicious. Emergency budget crisis, they said. All non-essential monitoring suspended, but the Deep Space Network stayed operational. Certain telescopes maintained priority access. Someone high up decided this was essential enough to keep funding during a crisis. What do they know that we don't? Chen called me into her office this morning. She looked older than last week. The stress is killing all of us. I need you to run probability models, she said. Worst-case scenarios. If it stays in solar orbit, what are the implications? You're taking the capture hypothesis seriously. I'm taking everything seriously. We have 2 weeks until perihelion. Give me numbers. I've been running numbers all day. Here's what they say. If 3I/ATLAS performs an Oberth maneuver and enters solar orbit, its mass is sufficient to perturb asteroid belt dynamics over millennial timescales. More impacts in the inner solar system, not immediately catastrophic but statistically significant over centuries. If it releases smaller objects during perihelion, those objects could reach Earth orbit within months. Depends on their velocity and trajectory. Could be probes, could be debris, could be something with intent. If it's broadcasting, someone might answer. We're assuming it came alone. What if it didn't? What if others are listening for signals from scouts? What if reporting back means more arrive? If the October 29th timing is deliberate, someone or something planned this around Earth's position. We're at a specific point in our orbit. Mars is at a specific point. The geometry is optimal for something. Observation? Deployment? First contact? The numbers don't comfort me. Maria sent new data from chemical spectroscopy at midnight. I'm looking at it now. There are trace elements that don't match any stellar population model, isotope ratios that shouldn't exist. Either our understanding of galactic chemical evolution is fundamentally flawed, or this thing was manufactured from materials processed in ways nature doesn't do. Could be contamination, she wrote. Or we're looking at industrial residue from 10 billion years ago. Industrial residue, from an object older than Earth, built by something we have no name for, traveling through space longer than multicellular life has existed on our planet. I can't prove it's artificial, but I can't prove it's natural either, and that uncertainty is breaking something in me. The Mars flyby is in 3 days. ESA and NASA coordinated all available Mars orbiters. Every camera pointed at the trajectory. High-resolution imaging across multiple wavelengths. If there's anything to see, We'll see it. I'm scared of what we might see. I'm more scared of seeing nothing and still not having answers. Tom thinks it will change trajectory after Mars, use Mars gravity for a small course correction. Testing, he said. If I were an automated system approaching an inhabited system, I'd verify my navigation before committing to final approach. Fly past an outer planet, see if calculations match reality, then make final burn. You're anthropomorphizing. Am I? Or am I just thinking like an engineer? This is what we'd do. This is what makes sense. He's not wrong. It terrifies me that he's not wrong. Sarah calculated the odds yesterday. 2% for the ecliptic alignment, 5% for the composition anomaly, 8% for the stable rotation, 12% for the timing. Individually explainable. Together multiplicative. The combined probability of all these factors occurring naturally is 0.003%. 99.997% chance. This is not random. That's not how statistics work, Director Chen said when Sarah presented. You can't just multiply independent probabilities like that. These aren't independent, Sarah replied. They're correlated. The alignment affects capture probability. The composition affects trajectory stability. The rotation affects observational profile. Everything connects. Chen didn't argue further. What could she say? Afilov published a new paper this morning. I've read it twice. He's careful, methodical, presenting only what the data supports. But the conclusion is stark. 3I/ATLAS exhibits characteristics inconsistent with natural formation and transit. Either our models are incomplete, or we're observing technology. He's going to be crucified again. But this time, more people are listening. My hands are shaking as I type this. It's October 13th. 2 days until Mars flyby. 16 days until perihelion. And I'm sitting here at 4 in the morning, drinking cold coffee, staring at data that suggests we might be watching something impossible become real. What if we're not alone? What if we never were? What if something out there, something old beyond comprehension, built vessels and sent them into the darkness? What if one of those vessels just arrived here? What happens on October 29th? I don't know. Nobody knows. But in 16 days we might find out. And I'm not sure we're ready for the answer.